Good morning, Becky. Good morning, Rachel. I'm sorry I couldn't be with you guys today. I am in Indianapolis, Indiana at the National Council for Teachers of Mathematics National Convention. There's math teachers everywhere. You would be absolutely terrified, but I'm having a blast, and I'm learning so many things that I can't wait to share with you guys. Lots of really interesting stuff, and in the meantime, I didn't want you to not have a math lesson for today, of course, or not miss my smiling face, so I thought I'd record a little something and send it to you, and then your substitute will be there and helping you go through the packet as well. But there's a new topic that we haven't gone over in class. We've briefly touched on it before whenever we talked about inequalities, but this is going to be solving a linear inequality, solving an equation, except it's an inequality, a non-equation. So here we go. Basically, you're going to have a problem that looks something like this. They're going to give you, hey, this is going to be a real easy one to start off with. I got my board here, so it's just like on there. If I've got 2x is greater than 8, then I would, for all practical purposes, just pretend like this were an equal sign. If this were an equal sign, then I would look at this and I say, well, here is my variable. They've multiplied it by 2, and that's what I need to fix. So I'm going to undo a multiplication by 2. I'm going to divide by 2. And over here, I'm going to divide by 2. And so we cancel our 2's. And x on this side, 8 divided by 2, a 4 on this side, but it's not an equal to, it's greater than. X is greater than 4. So we have our solution. X is greater than 4, and so we could try a number greater than 4. How about 5? The original problem was 2x is greater than 8. So if we used 5, then 2 times 5 is greater than 8. 10 is greater than 8, absolutely. Another number greater than 4 would be 1 billion. So 2 billion is greater than 8. Absolutely, fantastic. Another number greater than 4 would be 4 and 1/1,000,000th. So then we would have 8 and 2/1,000,000ths is greater than 8. And that works as well. Any number greater than 4. So let me erase this and we'll put a little slightly more complicated problem up. If I were to have not just a one-step equation, but maybe a two-step equation, if I were to have 3x plus 1 is less than or equal to 10. Then I'm going to solve this in the exact same way. I'm going to pretend like it's just an equal sign because all the rules are the same with the exception of one rule. And I'll get to that in just a second. We haven't encountered it just yet. So if I were to have 3x plus 1 equals 10, then the very first thing I do is I would subtract 1, of course. And so I would get 3x on that side and then a 9 on that side. But it's not equal to, it's less than or equal to. And then instead of multiplying by 3 like they did, I would do the opposite. I'm going to divide by 3. And divide by 3. And I get x is less than or equal to 3. Fantastic. Okay, so now any number less than or equal to 3. Well, 3 is less than or equal to 3. 3 times 3, 10. Or excuse me, 9. Plus 1 will give me 10. 10 is less than or equal to 10. That one works. That's why I'm able to use the numbers, because it's not just less than, it's less than or equal to. I could also use 0. 0 plus 1, 1 is less than or equal to 10. Or negative 100, that'd be negative 300 plus 1. Negative 299, that's less than or equal to 10. Any of those numbers is going to work. So in order to solve an inequality, it works exactly the same as if it were an equal sign. You just pretend like it's an equal sign, and all the rules are going to follow, with the exception of one rule, and here's where it is. There's something here that we haven't done before, and has to do with the negative. Let me see the negative there. But it's not just any time you see a negative. It only occurs when you multiply or divide by a negative number. The original number can be positive, negative, who cares? But if you multiply or divide by a negative number, then we're going to have to do something, because I'm going to do this one wrong. So you guys are watching, this is wrong. They divided by a negative 4, so I'm going to multiply by a negative 4. Cancel. X greater than negative 8. So I say, well, let me think of a number greater than 8. Greater than negative 8. How about 0? 0 is greater than negative 8. So I'd have 0 divided by negative 4. 0 is greater than 2, and 0 is not greater than 2. That is not the case. If you ever multiply or divide both sides by a negative number, then what you need to do is take this inequality, it was facing this way, and you need to turn it around. So instead of x being greater than negative 8, it's going to be less than negative 8. Now normally, whenever we have just an equal sign, we can multiply or divide by a negative number all day long, and that equal sign turning around is still an equal sign. But the less than or greater than sign do change whenever they turn around. So x is less than negative 8. Negative 10 would be an answer. So negative 10 divided by negative 4 is positive 2.5. 2.5 is greater than 2. That works. So by using the one rule, if you multiply or divide by a negative, then you must flip the sign. And by sign I mean greater than, less than, greater than or equal to, or less than or equal to. Your inequality sign must be flipped around. Okay, so that's the rule. Once you go through and solve, you get a solution, then you can put it on a number line. So I'm going to do one like that real quick and just graph the solution. You're going to be doing that on your homework today. So if we were to have, let's say, 7x minus 1 is less than or equal to 20. We're going to solve it, and we're going to graph it. If they subtract 1, then I'm going to add 1. So I'll add 1 to both sides. Plus 1, 7x is less than or equal to 21. Very good. Okay, so now I've got this. And then I'm going to, well, they multiplied by 7, so I'm going to divide by 7. Divide by 7, divide by 7, and I get x is less than or equal to 3. Just for fun, we could check and make sure before I move on. A number less than 3, how about 2? 7 times 2, 14, minus 1, 13. 13 is less than or equal to 20. It is going to give me the correct answers. Now here's what I'm going to do. Number line. That number line needs to have 3 on it. So I'll do 3, 4, 5, and then a 2, a 1, and a 0 on this side. Since all numbers less than or equal to 3, I'm going to say, well, 3, but it's equal to 3. It counts. So I'm going to fill in that hole. And its x is less than or equal to 3, and all numbers less than are on this side. So we take any numbers to the left of 3. X is less than or equal to 3. If it were just less than, then that says, well, a number less than 3, 2.5, 2.9, 2.99, 2.99999. But as soon as I get to 3, it doesn't work anymore, because then that would be me saying 20 is less than 20. But it's not less than, it's equal to. So then I would have this hole here. I says I can get as close as I want to 3, but I can't actually touch 3. If you have any other questions on it, then talk to your teacher. They'll be able to walk you through it. We'll go over it again whenever I get back to class next week, just to make sure. I'll give you a little more harder problems, but there's no new rules. That's it. I hope you guys have a great Saturday. I will see you next week. Bye.